Hi, this is week 1 of our chemistry course, and today we're going to go ahead and talk about nomenclature. Nomenclature is a word that means naming molecules. In particular, the molecules we're going to be looking at are organic compounds, which are found in organisms, and a type of organic compounds we'll also be looking at hydrocarbons. Those are molecules that have carbon and hydrogen. We'll be starting with very simple molecules for this lesson. They can get very complicated, but we're just going to stick to the simple compounds. So, our objective for the lesson is that students will be able to solve for the formula of simple organic compounds. Again, we're just keeping with very simple compounds and hydrocarbons as well. Alright, so let's get started. By the way, you will need a periodic table for this lesson. If you have one, great, bring it out. Have it handy, you will need it for this lesson. Alright, so what is an organic compound? An organic compound is one that is made of two nonmetals attached to each other. That's what an organic compound is. Two nonmetals attached to each other. What are nonmetals? Well, nonmetals are found on this corner of the periodic table right here in orange. And that also includes hydrogen. Those are compounds that are not very good at conducting heat. They are very bad at conducting electricity. They tend to be very brittle. That means they can break easily. Those are nonmetals. And again, they're found in this corner. If you have your periodic table handy, you can go ahead and start at this corner and go down one, across, down across, down across, as you see in this red line on my screen. And every one to the right of that is a nonmetal. Also, don't forget, hydrogen is also a nonmetal. So that makes them very easy to identify on the periodic table. Everyone to the right of this red line. Alright, naming these organic compounds requires some Greek prefixes for numbers. Alright, so it says organic molecules use Greek prefixes, so they go in the front of the word, such as, for number 1 is mono, number 2 is di, 3 is tri, tetra is number 4, penta is number 5, and so on. Alright, you will see some of these look familiar to you. For example, for an octopus that has 8 tentacles, you see octa, an octopus. A decade has 10 years. The pentagon has 5 sides. Mono, in the game Monopoly, you win when there's only one player left. A tricycle has 3 wheels. And in the original game of Tetris, each piece had 4 little squares. So that's where it gets its name, Tetris. Alright, moving along, the prefix mono, though, for one, mono meaning one, it's only used for the second atom, not the first. So for example, a compound like carbon monoxide has 1 carbon and 1 oxygen, but I will not say monocarbon monoxide. Now, mono is only used for the second atom. And the suffix, that means at the end of the word, the suffix ied, ide, is used to modify the second atom. So for example, something like bromine becomes bromide because we use the IDE ending. Chlorine becomes chloride. Oxygen becomes oxide. Nitrogen becomes nitride, and so on. So they all end with this IED. That's going to be the suffix that we're going to use. Alright, so let's go ahead and get started with example 1. Find the formula for the following. A, the first one, carbon monoxide. Notice mono, it's only used for the second atom. In this case, is oxygen. I also want to take a moment to point out, notice that the IED suffix is used in all of them. All of these organic compounds are going to end with IED. So let's start with the first one, carbon monoxide. So you look up on the periodic table, which you should have handy, and you find the symbol for carbon, so you just write it down. It's got no prefix in front of it. That means that it's a number 1. When there's no prefix, there's 1 carbon. Now in chemistry, we don't really write ones. So it's there, but we're not going to write it. The second one is oxide. As I mentioned, that's really oxygen. Its ending's been modified with that IED ending. That means that it's attached to another atom. How many oxygens are there? Mono, meaning 1. So there's only 1 oxygen. So there's the answer for our first one, A, CO. That's carbon monoxide. We'll talk a little bit about carbon monoxide a little bit more later on. Next one, B. B is dinitrogen pentaoxide. Di means two, so there are two nitrogens. So I write N2. Pentaoxide. Penta meaning 5, so there are 5 oxygens. So I'm going to write it O with a small 5 on the bottom right corner. So there's the answer for B. N2O5 dinitrogen pentaoxide. Letter C is nitrogen dioxide. So again, it's just nitrogen, no prefix. That means that it's only one nitrogen. And I'm not going to write the ones because we know don't write ones. And dioxide meaning di meaning two oxygens. And O2, by the way, this is also known as nitrous oxide. It's laughing gas. Next one, carbon tetrabromide. Tetra means 4 from the Greek name, so I just write carbon. Tetrabromide, 4 bromides. So symbol for bromide, again, you get these symbols from the periodic table. Symbol for bromide is Br, and tetra meaning that there's only 4 of them. So there's your answer. Last one, letter E, phosphorus trifluoride. Phosphorus has no Greek prefix in the front, so again, there's only one of them, so I just write P. I don't put the 1 because we don't write ones. And trifluoride, tri meaning 3. Fluoride is fluorine. So there are 3 fluorines, and there are answer for example 1. Now, I mentioned that I was going to talk a little bit more about carbon monoxide. This is one of those molecules that every science teacher should talk about it. Carbon monoxide is a colorless gas. That means you cannot see it. It is an odorless gas. You cannot smell it. And it's also a very toxic gas. And it's always worth bringing up to people. Sadly, every year people die from carbon monoxide intoxication. And most of them happen by accident. Pretty much anything that burns is going to give you carbon monoxide. Anything that burns will give you that. Most scenarios happen when there's something burning, it's producing it, and it collects inside of a house or in a garage, and then it becomes toxic. A common example you see a lot in places where it's very, very cold. People will be in their garage, and they'll turn on their car inside of the garage and then stay there as perhaps they're plotting the route for the day where they're going to drive to, and the car's producing carbon monoxide, and sadly people die frequently with that. Anything that burns will produce carbon monoxide, so you really want to warm up your car outside of the garage, and at the very least have your garage door open. Another scenario this has actually happened is perhaps in a snowstorm, power gets knocked out of a home that cannot be heated, so some folks will bring into their home their backyard barbecue. And the barbecue, they'll go ahead and get it going, and it's going to go ahead and create, again, anything that burns will create carbon monoxide. It creates this toxic gas, and the side effects that people begin to feel is that they just feel sleepy, and they'll go take a nap, and sadly they don't wake up. Alright, so that also is true for, again, same scenario. Power is out. They bring in a gas power generator to run electricity, but again, anything that burns fuel is going to go ahead and give you that carbon monoxide, so it's toxic. So that's one of those gases that every teacher should talk about. So please be careful. If it's burning, it's going to go ahead and create this toxic gas, and it builds up. Alright, what about your fireplace? Well, that one is safe, and the reason why it's safe is because your fireplace uses the chimney to get the smoke outside of the house, so it's safe. Alright, so please be careful with that. Alright, let's get back to our lesson on naming molecules. In our second example, we're going to go ahead and do the opposite. I go ahead and I give you the molecule, and now you have to go ahead and give me its name. Alright, so sample 2, name the following organic compounds. SF2. Let's start with the S. Again, you need your periodic table handy. If you look for the S's towards the right hand side, you know that it's sulfur. No number there, that means it's just one of them, so all I have to do is write sulfur. That's it. The other one is F with a small 2 at the bottom right corner. That means that we have 2 of that F compound. So I'm going to start with writing a di, because di means 2 for our Greek prefixes. F is fluorine, but remember the second molecule gets that IDE ending. So instead of fluorine, it becomes fluoride. So this is our answer for A. The next one, Ni3. N is nitrogen, so I go ahead and write it down. Nitrogen. 3 I's. 3 is tri, meaning 3 in the Greek prefixes. And I is iodine, but again we have to add that IDE ending, so it becomes, instead of iodine, it becomes iodide. And yeah, it has 2 I's next to each other. It looks a little strange. That's the proper spelling. If you only put 1 I, people will forgive you. It's fine. The next one is CF4. Carbon is the first atom. F is fluorine, becomes fluoride. Notice that there's 4. So our Greek prefix for 4 is tetra. And the F is fluoride. Again, with that IDE ending, all of them will have that IDE ending. Letter D, N2O3. N2, now finally we have the first atom have a number there, a subscript at the bottom. And so that means that there's 2 nitrogens. So I'm going to write dinitrogen. 2 nitrogens. 3 oxygens is spelled tri for 3. Oxygen, when you add that IDE ending, it becomes oxide. So dinitrogen trioxide will be the name for D. And the last one, H2O, is water. Everyone calls it water. You're never going to see this name ever. It's just water, but we'll write it down anyway. There's 2 hydrogens. I'm going to write dihydrogen. 1 oxygen. Monoxide. Dihydrogen monoxide. Oops, forgot the N right here. Pardon me. Dihydrogen monoxide. Again, you're never going to see that. Everyone calls it water. Alright, so that takes care of our organic compounds. Up next, we're going to switch gears to talk about hydrocarbons. Now, hydrocarbons, those are compounds that have carbon and hydrogen. And we're only going to stick to the simple ones at first. They can get very complicated though. For example, you see this picture right there. The black spheres represent the carbon, white spheres represent the hydrogen, and they can get very complicated, but we're only going to stick to the simple ones. So hydrocarbons are a type of organic compounds that are made up of hydrogen and carbon. Those are hydrocarbons. They are named using the following stems. So the name of the hydrocarbon is found by counting the longest carbon chain. So if there's only 1 carbon, so C1, that would be meth. Then after that it goes eth, prop, bute, paint for 5 carbons, hex, hept, oct, non, dec. You'll notice from 5 on they look very similar to the Greek prefixes. It's only the first 4 that have their own unique names. After number 5, yeah, they follow the Greek prefixes. Alright, so those are the stem of our words that we're going to be using to name these. So, that's just a piece of it though. We're going to add a suffix at the end as well, and we're going to add a prefix to some of them, but not all. So let's start with the suffix. The suffix for the name of hydrocarbons is based on the type of bonds found in between the carbon atoms. So for example, if we only have 1 bond in between the carbon atoms, so something, here's a carbon, there's a line representing the bond, that is ANE for a single bond. So for example, 2 carbons would be eth, and then I would add the ending, the suffix ANE. But what if that carbon atom had 2 bonds attached to it? So you see the 2 lines represents that there's 2 bonds. Again, I still have 2 carbons, so I'm going to put the same stem. eth, but now I use ene. What if you have a triple bond? So I have a carbon atom attached to another carbon atom with a triple bond, still two carbon atoms, so I would call that one eth, still, because there's only two carbons, but now there's three lines, three bonds holding it together, so that'll be a yne. So this would be ethane, ethene, ethyne. So that depends on the number of atoms, on the bond holding the atoms together. Now, for our lesson, we are just getting started with nomenclature, naming these hydrocarbons. So we're only going to stick to single bonds just to keep it simple. So we're only going to use the suffix ane for all of our answers, just to keep it simple. Later on we can go ahead and get more complicated as we learn more. But for right now we're just going to stick with that ane ending. Alright, so that's the suffix. Next. They do have a prefix, but not all of the hydrocarbons do. Some hydrocarbons require the prefix cyclo, meaning like a circle or a ring. Cyclo. That means that the molecule has this shape right here. So here they have 1, 2, 3, 4, 5 carbon atoms, and notice that they're a circle. So this one you would put the prefix cyclo. On the other hand, this one has the same number of carbons, 5, but notice it's a line or a chain. You would not put the prefix cyclo for the one on the right. You would put it here when it's in the form of a circle, cyclo, but as a chain, as a straight line, you do not put that cyclo prefix. So only some of them will need it. Alright. So, naming those, let's say I have 5 carbon atoms. So there's my first one. Notice in the shape of a ring versus 5 carbon atoms in the shape of a chain. So they both have 5. So the stem of the word would be pent for both of these. Pent. Both of them will have the same stem because they have pent meaning 5. Now the suffix, the ending, you see how there's only one line for all of them, and for this lesson we're only going to stick to single bonds only. For that reason, they're all going to have the same ending, ane. So this is pentane, pentane. Alright, so far it's the same name, but look at this shape. It's in the form of a circle, a ring. So therefore, that one is going to need the prefix cyclo in front of it. So its full name is cyclopentane. As opposed to this one, it's just pentane. So it's in the form of a ring, you had cyclo. It's in the form of a chain. No, you don't put cyclo, you just write pentane. That's it. Alright, now, students ask, how do I figure out if it's a ring when they just give me a formula? For example, I write C5H10 versus C5H12. Then I ask you, well, what's the name of this one versus that one? And you can, most students will tell you, well, I know it's 5 carbons, so it's pentane, but I don't know if it's a ring or not. To get the answer to whether it's a ring or a chain, well, you have to use hydrogens. Alright, so let me backtrack a little bit. Carbon can only have 4 bonds total. So to this carbon atom, I already have 2 bonds, and I'm going to add 2 hydrogens there. Same thing for this one, that as well, and so on. So you will notice that every single carbon has 4 lines coming out of it. That means that there are 4 bonds. Notice also that for every carbon, what do you have? 2 hydrogens attached to it. So therefore, our formula is for whatever the carbons are, the hydrogen is going to be double that. And that's what you see right here. For rings, whatever the number of carbons is, the hydrogens will be double. On the other hand, what about the chains? Well, that has a slightly different formula. Alright, whatever the number of carbons is, the hydrogens will also be double plus 2 more hydrogens. Double plus 2. Why the plus 2? Well, let's take a look at this formula. So I'm going to add hydrogens. Again, each carbon atom can have 4 bonds. So there you have it. And then you'll notice that there's 2 hydrogens for every carbon. That's why it's double the carbons. For every carbon, there's 2 hydrogens. But this one also has 2 additional carbons, 2 additional hydrogens at the end. So that's what gives you the +2. So now again, going back to our original question, how would I know which one of these requires the prefix cyclo? I know they're pentanes. The answer is you look at the hydrogens. Alright, so that's a 10. That's exactly double the carbons. That's the one that needs the cyclo. This is in the form of a ring. Versus this one has 12 hydrogens. That is double the carbons +2. No, that means it's in the form of a chain. No prefix for that one. So you use the hydrogens to figure out if you have a ring or a chain. Alright, so now that we've done that explanation, let's go ahead and do some examples. So for our third example, I'm going to go ahead and do all of these guys. They ask us, write the formula for each of the following hydrocarbons. It would be helpful to have the names for the stems for all of these ones handy. Again, I'm going to go back to that slide, and I'm referring to this one. Like for example, 1 carbon is meth, 2 carbons is eth, 3 carbons is prop, 4 carbons is bute. If you have this handy as we go through it, that would really help you out. Alright, so let's go ahead and start naming these guys. Alright, methane. Meth meaning 1 carbon. So there you go. And it's a hydrocarbon, so it's got carbon. The other element is hydrogen every time. How many hydrogen atoms? Well, check out the name. It does not have the cycle in front of it. So that means you need to get the carbons and double it and add 2 more. So double the 1 is a 2, add 2 more, that gives you a 4. So there you have it. Alright, to stay consistent, notice that I said earlier we never put 1s in chemistry just to save some ink. So that's more likely what you would see. Let's move on to letter B. Butane. Bute means 4, so it's got 4 carbons. Alright, so that's the first part. It's hydrogens, how many? Again, no prefix, no cycle in front of it, so that means we're going to double the carbons and add 2 more on top of that. So double the 4, that gives you an 8, add 2 more, that's 10. That's how we figure out letter B. Letter C, cyclo. Oh, this was a cyclo. Cyclopropane. Prop means 3, so there's 3 carbons there. Now how many hydrogens? Because it said cyclo, all we have to do is double the carbons. So if you got 6 carbons, therefore the hydrogens will be just double. That's it. C3H6, that's the answer for letter C. Letter D, heptane. Heptane, hep meaning 7. So that means I have 7 carbons, and there's no cycle in front of it, so that means I'm going to double the carbons. So double 7 is 14, and then I'm going to add 2 more on top of that.